Matter is made up of billions of tiny particles called atoms. Each atom has a nucleus that consists of protons and neutrons. The nucleus can be split apart by bombarding it. Enormous energy will be released when nucleus is split. Do you know what this energy is? Let's find out how this energy is released. At the end of this lesson, you should be able to describe the production of nuclear energy through fission. Describe the production of nuclear energy through fusion. Observe the animation carefully. It shows a heavy nucleus being bombarded by a neutron. What happens to the heavy nucleus after being bombarded by the neutron? Put a tick for each statement after your observation. What is released when the heavy nuclei is bombarded by a neutron? Click the answer button to check. When a heavy nucleus is bombarded by a neutron, energy is released. From the previous animation, you have learned that a heavy nucleus can be split. When a heavy nucleus such as uranium-235 is bombarded by a neutron, the nucleus splits to form two other lighter nuclei and emits more neutrons. A tremendous amount of energy is also released. This energy is in the form of heat and light energy. The energy generated is known as nuclear energy, and the process is known as nuclear fission. Neutrons that are released through nuclear fission may cause other heavy nuclei to undergo nuclear fission. Thus, a single fission caused by a neutron can lead to a series of nuclear fissions. This process is known as a chain reaction. In a chain reaction, tremendous amount of energy is generated. If the chain reaction is uncontrolled, an explosion may happen. This is the basis of the production of the atomic bomb or nuclear weapons. Now, look at this animation. What can you deduce from the animation? This process is known as nuclear fusion. An example of this process is the fusion tritium and deuterium nucleus. When tritium fused with deuterium, heavy nucleus of helium is produced. At the same time, a neutron is also produced and a tremendous amount of energy is released. The process of nuclear fusion can also occur naturally in the Sun. The Sun generates a tremendous amount of heat and light energy through the fusion of hydrogen atoms into helium atoms. All living things on Earth rely on this energy to sustain life. Drag and drop the correct words into the empty boxes. Click the Check Answer button to check your answer.
Your answer is correct.
Drag and drop the correct words into the empty boxes. Click the Check Answer button to check your answer.
Your answer is correct.
Click the correct answer. Which of the following are true about nuclear fission? 1. During nuclear fission, energy is released. 2. The fission products weigh less than the original atom. 3. Two nuclei combine to form a heavy nucleus.
Your answer is correct.
What is a chain reaction? A. A rapid series of nuclear fissions. B. An uncontrollable series of nuclear fusions. C. A continuous production of nuclear fusions. D. A self-sustaining production of nuclear fusions.
Your answer is correct.
What happens during nuclear fusion? 1. Lighter nuclei combine to form a heavy nucleus. 2. A lighter nucleus splits into heavy nucleus. 3. A tremendous amount of energy is released.
Your answer is correct.
Figure shows a process of nuclear fission. What is particle X and Y? A. Electrons, neutrons. B. Neutron, heavy nuclei. C. Heavy nucleus, neutrons. D. Neutron, lighter elements.
Your answer is correct.
What is produced when the two isotopes of hydrogen, tritium H3 and deuterium H2, combine during the nuclear fusion reaction? 1. Helium-4. 2. Krypton-92. 3. A neutron.
Your answer is correct.
In this lesson, we learned that nuclear energy can be generated through nuclear fission and nuclear fusion. Nuclear fission is a process whereby a heavy nucleus splits up into two or more lighter elements when bombarded with neutrons. This process will release large amount of energy. A single fission can lead to a series of nuclear fissions. This process is called a chain reaction. Nuclear fusion is a process whereby lighter nuclei combine to form a heavy nucleus. Large amount of energy is released during this process. In 1905, Albert Einstein proposed his popular mass-energy equation E equals mc square. The fission process exploits the relationship between energy E and mass m to generate energy. During nuclear fission, a nucleus splits into several smaller fragments. These fragments or fission products are about equal to half the original mass. 2 or 3 neutrons are also emitted. The sum of the masses of these fragments is less than the original mass. This missing mass is called mass defect. It is converted into energy according to Einstein's equation. This mass-energy equation can be used to change mass to energy. It can also be used to invent nuclear weapons such as nuclear bomb.